All right, one more example of the washer method here, and I'm going to, I've chosen a problem that's going to be revolved around the y-axis instead of the x-axis. So we need to do a little bit of changing here. So let's take a look at our first function there. So if we write this with respect, x is our solution, x equals y minus 2. That means f of y equals y minus 2. This one here, we have 2x equaling y plus 1, which means x equals y plus 1 over 2, or we'll call this one g of y equals y plus 1 over 2. So those are going to be the two functions. Now we need to graph this stuff. Probably just graph them as they stand, though. Let's go, say 5 or so. See if we need more. All right, so in blue, we'll do that first one, y equals x plus 2. So when x is 0, y is 2. And just going to go up after that. So it's going to go up by a factor of 1 each time. So it's going to do something like that. This is y equals x plus 2. Okay, the orange one. Y equals 2x minus 1. Well, at 0, I guess we need to add this number here. At 0, we have negative 1, and this is going to go up with in a much steeper fashion. So this is y equals 2x minus 1. We have to find out where they meet, right? So when does 2x minus 1 equal x plus 2? Well, looks like x equals 3. Moved one x over to the left. I moved the negative 1, adding 1 to each side to the right. That's what we have, which means that where's the y value? So y equals 3 plus 2. That means y equals 5. So this point here is 3, 5. Okay, and that's oddly enough where it showed up on the map. So that's on the grid. That's good. All right, so now we need to calculate the volume. And again, we're looking at, let's pick a color we didn't use. There's green. So this is the area of interest here. And it even goes down below the x-axis. Again, we're rotating around the y-axis. So for y values of -1 to 3, we can do that, or we can just take the whole thing, -1 to 5, and then see what we do with that. All right. It's going to go to 2. Okay. So since we're using the washer method, we'll use, there is no washer to be had from -1 to 3. More work over here so I can still see the graph. So volume, the bottom part of the volume, I'm going to cut off here. So this is going to go, we've got the pi in front, -1 to 2. And we're looking for this function here. So y equals 2x plus 1, which we determined to be this one here. So that's going to be our g of y, I guess. So that's y plus 1 over 2 quantity squared dy. So we'll look at just that area first, and then we'll add the next part as well. Well, I can probably fit some of this in here, right? All right, so let's just do it on another line. we'll finish this part. We'll call this area 1. So this is volume for area 1. All right, that's pi. Let's square that out, I guess. Need to do that or not. Doesn't look like we need to, because I mean, realistically, that's just, if we let u equal, so that's good. So we got pi by 4 out here, -1, 2, we just square that, and we have y plus 1 squared. So if our u is y plus 1, our du is just dy, so that's going to be pi by 4, and that'll be y plus 1 quantity cubed over 3. All this is evaluated from -1 to 2. All right, so we've got pi by 4. We'll just call it, let's call this pi by 12. And just remove the y plus 1 cubed. So we put in a 2, we get 2 plus 1 cubed, and then minus -1 plus 1 cubed, which is, this is just 0. So this is going to equal 3 cubed is 27, or I guess 3 squared is 9, and then we can cancel out part of this. So this is going to be 9 over 4 pi. That's this part of it anyway. That's for section 1. So let's go and choose another color and deal with, let's do, I don't know, let's do this light blue here. And this will be 2. That's a little too light. Let's use this. There we go. All right. So that one's going from 2 to 5. And our f of x is going to be that, which would, I guess, f of y would be our g of y, and g of y would be f of y. So because our 1 on the bottom will be what our f of y came out to be. So let's do that. So this is for volume for part 2. And that goes from 2 to 5. We got the pi out front. And now we need to do the subtraction of the squared. So we have y plus 1 over 2 quantity squared minus, what's the other one? Y minus 2. That quantity squared, all dy. All right, again, we've done this one here. We know the integral of this, we can pull out the 4. So this is going to be 1/4. And then we're going to have y plus 1 cubed over 3 from our previous one. That's the first part on the inside. And then we have this y minus 2. In a similar fashion, this is going to be y minus 2 quantity cubed over 3. All this is evaluated from 2 to 5. All right, so evaluating at 5. This is 5 plus 1 cubed over 3 minus 5 minus 2 cubed over 3. And then we have a 2, so 1/4. 2 plus 1 cubed over 3 minus 0. So I'm not even worried about minus 0. Okay, so V2, got 6 cubed, so 36 times 6, 216. Looking for 216 over 12 minus 3 cubed is 27 over 3, which we can reduce in a minute. And then this will just be a minus here. 2 plus 1 is 3, so that's 1 over 4, and that's another 27 over 3. Okay, we've got 216 over 12 minus 27 over 12. I guess we can just leave that alone. Well, we'll just leave that alone and see what happens. Let's see. Can add a 9. So 189 over 12. And then this is, I can divide that one by 3. I don't know if that's going to help me or not. Probably not. So let's just leave that as a 12. And let's change this other guy to 12. So we're going to multiply 27 by 4. So that's 8. So 108 over 12. All right, so now we have 81 over 12 pi. So when we add them together, V1 V1 plus V2 is equal to 9/4 is equivalent to 27/12. And then we have 81/12. And that's all times pi. So 108 over 12. And that's just 9. So this is our volume. So volume equals these two together. So our volume is 9 pi via a long and winding road.